Welcome to Graphing Trig Functions Podcast 5. So I just couldn't get it all in that last podcast. I think I only have about 5 slides left though. All right, let's see if we can finish this off. All right, so we're going to graph y equals tangent 2/3 x. Step 1, identify b and find the period. So b is the coefficient in front of x. b equals 2/3. So our period is going to be pi divided by 2/3, which is the same as pi times the reciprocal, times 3/2, or 3 pi halves. So notice now we have a longer period. So we want to find the vertical asymptotes. We're going to set bx equal to negative pi halves and bx equal to pi halves. And it is bx. So bx is right there, 2/3 x. It will always be bx. And it will always be equal to negative pi halves. And it will always be bx equal to pi halves. So we have 2/3 x equal to negative pi halves. And we have 2/3 x equal to pi halves. So we're just going to multiply by the reciprocal here. So we'll multiply both sides of this equation by 3/2, right? And then we'll have an x on one side, and we'll have our vertical asymptote. Our vertical asymptote is going to be, we're going to have one at negative 3 pi fourths. Right, so let's put negative 3 pi fourths in our table. That's our first value, and we put an x there because there's a vertical asymptote. We won't be evaluating. There is no y value. We'll do the same thing for the other vertical asymptote. We'll multiply both sides by 3/2, and here the x will the 2/3 will cancel with the 3/2, and we'll have x equals 3 pi fourths. So that's going to be our 5th point, and that's going to be another vertical asymptote. So to find our key points where the other 3 are going to occur, we take our period, which is 3 pi halves, and we simply divide that by 4. That's going to be the same as 3 pi halves times 1/4, or 3 pi eighths. So now we're just going to count from negative 3 pi fourths by 3 pi eighths. Right? So negative 3 pi fourths. And actually, let me change that to eighths right away so we can add that. Negative 3 pi fourths is the same as negative 6 pi eighths. So if we add 3 pi eighths to it, my shadow is blocking me, so I can't always see. Negative 6 pi eighths plus 3 pi eighths is going to give us negative 3 pi eighths. And that's our second x value. And we'll evaluate to find the y value that goes with it. But let's keep counting. Negative 3 pi eighths plus 3 pi eighths gives us 0. That's the next value in our table. And then 0 plus 3 pi eighths is going to give us 3 pi eighths. If we added another 3 pi eighths, we'd have 6 pi eighths, which is the same as 3 pi fourths. So you see, we did just count from one vertical asymptote to the other. Let's get our y values by evaluating. And I'm actually going to draw us out 3 coordinate planes. Okay? All right, so the first one there, we need to plug in. I should have really separated these a little bit. Let's give myself a little bit of space to evaluate too. All right, so 1, 2, and let's put the third one over there. All right, so we have y equals tangent 2/3, and I'm going to plug in negative 3 pi eighths. All right, so that's going to reduce. I'd have negative 6 over 24. That's going to reduce to negative pi fourths. So y equals tangent negative pi fourths. And we're going to evaluate it. Okay? So negative pi fourths is going to go right there. Right? That would be negative pi fourths. if we went the other way, right, this would be negative pi fourths plus 2 pi, which would give us 7 pi fourths. So this complementary angle here is 7 pi fourths, and if we subtract 2 pi minus 7 pi fourths, our reference angle is pi fourths. But you probably figured out that if I'm only in the fourth quadrant, that a negative pi fourths is going to be the same for in terms of our reference angle as pi fourths. So when we evaluate our reference angle, this is pi fourths. Right? It's just the fast way to get to, you go to the fast way to the x-axis, and we use that triangle to evaluate our angle. So we're going to use the same measures to evaluate negative pi fourths as we would pi fourths. It's just that we're going to remember that the y values are negative because we're in the fourth quadrant. And this is a 45-90 or pi fourths, pi halves, right triangle. And so the x value there, the adjacent side will be 1, the y value will be negative 1, and not that we need it, the hypotenuse is the square root of 2. So if we evaluate tangent at negative pi fourths, that's just going to be the opposite side, which is negative 1, over the adjacent side, which is 1, or negative 1. And so that's the value for negative 3 pi eighths, negative 1. Let's do the same thing over here. So we have y equals tangent 2/3 times 0. Well, that's just going to be 0, right? Y equals tangent 0. All right, so we're just going to evaluate what tangent is at 0. Right? So this is this point right here. Right? And that point there is 1, 0. Remember that tangent is y over x, so that's going to be 0 over 1. So this value here is just going to be 0. And let's get our last one. All right, so we're going to plug in 3 pi eighths. So y equals tangent 2/3 3 pi eighths. And that's going to be, again, 6 over 24, or reduced to pi fourths. So y equals tangent pi fourths. This angle is its own reference angle because it's in the first quadrant. All right, so if this is pi fourths, trying to squeeze that in there, the opposite side is 1, the adjacent side is 1 because x and y are positive. The hypotenuse would be 2, not that we need it, because tangent is the opposite over adjacent, so 1 over 1 or just 1. So that means our last value in our table is 1. So now let's just label our graph and graph it. All right, I'm going to go up by, I got to make it all the way to 3 pi fourths. Let's go up by pi fourths. So this is pi fourths, this would be pi halves, this would be 3 pi fourths, this would be negative pi fourths, this would be pi halves, and this would be 3 pi halves. This is on a, I don't know if you can see it, this is on a coordinate plane. I just cannot see those values, I can't see those lines. So I'm just doing the best I can. So this is negative 1 and this is 1. Let's graph our vertical asymptotes. We have a vertical asymptote at, whoops, one of these numbers has the wrong denominator. We have a vertical asymptote at negative 3 pi fourths. And we have one at 3 pi fourths. And then we have 3 values to graph. We have negative 3 pi eighths. So that's halfway in between pi fourths and pi halves. And so that's going to be negative 1 right here. Then we have the point 0, 0, and then we have 3 pi fourths 1. So this would be our graph here. Notice that we had the same x and y values. I made it nice and friendly. What's different about this graph as opposed to the graph we did earlier? Well, if you notice, it has a different period. Our other one, we had vertical asymptotes at 3 pi fourths, and this one is only at pi fourths. So this one has a much smaller period, and this one is more stretched out. As soon as it comes up here. This one's more stretched out horizontally. And I think we're done with this graph. All right, I think I have one more, and I think it's mostly done. I just we'll go over it with you. And actually, it's the graph that oh no, it's a different graph. Let me go over this one, and I just added one little thing to it. I added a +2. How would that change the graph? All right, so I already have this one graph, and it looks so pretty, and I think I can go a little faster if I leave it that way. First of all, we have a negative a value. So if a is negative, it's going to reflect our graph, and it will be going down instead of up. That's the first thing. So we have to notice that. Step 1, we have to also identify b and find the period. B is 1/2. It's the coefficient in front of x. So the period is pi divided by 1/2, or 2 pi. We find our vertical asymptotes by setting bx equal to negative pi halves and bx equal to pi halves. So I have 1/2 x equals negative pi halves. If I multiply both sides by 2, I have x equals negative pi. That's the placement for one vertical asymptote. And then we have 2 times 1/2 x. That will give us x equals pi is the other one. All right, so our vertical asymptotes are at negative pi and pi, and I put those in the table there. And I put x's because there won't be any y values there. Those are just vertical asymptotes. We find our key points by taking our period and dividing by 4. So that's going to give us 2 pi divided by 4 pi halves. So we're just going to count up by pi halves. So negative pi plus pi halves would give us negative pi halves. Negative pi halves plus pi halves gives us 0. 0 plus pi halves is pi halves, and pi halves plus pi is, plus pi halves plus pi halves is pi. And we evaluate the trig function at the key points. All right, so the key points being negative pi halves, 0, and pi halves. The values we get when we count up. All right, so tangent 1/2 times 0 is just going to give me 0, so that's 0. I have y equals negative 3 tangent 1/2 times pi halves. So notice I put I simplify that, so that's going to be pi fourths. All right. Tangent at pi fourths is 1. We saw that, right? Enough times. But I've got a negative 3 there. So when I'm simplifying this, tangent pi fourths here is equivalent to 1. This right here is the same as saying negative 3. Oh, I have it over here. Negative 3 times 1. So that's going to give us negative 3. And y equals negative 3 tangent negative pi fourths. All right, that's going to be negative 3. That's going to be negative 1 over 1 times negative 3. That's going to be the same as negative 3 times negative 1, or positive 3. So that's where our 3 graph values came from. All right, so in blue there, I have the base graph without the translation. All right, so it would be reflected, but not translated anyway. And there I have the red graph, which has been translated. On the blue graph is the points. This would be the point pi halves 1. And this here, right there, would be the point, excuse me, that's negative pi halves. Left off the negative. And this point over here is pi halves negative 1. All right, so it would be at 1 and negative 1, but the amplitude change changes that to negative 3 and 3. Oh, excuse me, did we already put that when I graphed it? Oh, I already included that, I suppose. Yeah, I already included that. I'm sorry. The blue graph already has the amplitude change. Excuse me. Without the amplitude change, it'd be at 1 and 1. But I'm sorry, the blue graph, I already took care of the amplitude change. The only thing different between the blue graph and the red graph is the shift. So the blue graph here is, I forgot about the shift, is y equals negative 3 tangent 1/2 x. The red graph is just shifted up 2. So literally, we would just take the values that are in the table there and add 2 to it. So it's going to be at 5, at 2, and at -1. That's the values on the red graph. So this one here is negative pi halves 5. This is 0, 2. And the last point here is at, well, it should be right here. And that's pi halves, oh, excuse me, that's 1. That's 1. I'm looking at the wrong value. So that's going to be up here. Pi halves 1. All right, so the values that are on the blue graph, that blue graph is the values in that table there. The red graph is the shift up. So I'm showing you both an amplitude change and a shift up. If you can do an amplitude change, that would be probably good enough for me. On the shifts up, we would just then add them to our y values. But at this point, I think just a regular trig function with the period change or maybe an amplitude change would be good enough. Notice it doesn't really change our graph that much. It just makes it take a little longer to get closer to the vertical asymptote. But other than that, our graph looks pretty much the same. It's not quite as dramatic as sine and cosine in terms of the amplitude. So I hope that this, I'm basically out of my time. I hope this was okay and you understood that. And heck, you could watch me again. I could say it again for you. And if you have questions, write those questions down and ask me in class, because I can certainly go over them with you on Monday. And this is the last assignment. It's in the classwork already. And when you graph these, notice it says using the 5-point method. That's the one I've been showing you. All right? It needs to be graph like the examples in class. All right? That is my expectation. I want you to really understand these graphs. And this is the closing. I decided to keep it as an easy closing. I'm hoping you can read this okay, that it's not too pixelated. This is the end of my podcast, but if you want to hang out here with me for 30 seconds, I'll read those just in case you're having any trouble seeing them. Otherwise, well, you may as well answer the questions while I'm reading them. What the heck, right? This is your closing. You do not need to write the sentence. Just fill in the blanks. All right, so question 1 for the closing is one period of a sine or cosine function is called one blank of the sine curve or cosine curve. So kind of another word for period. A blank of a sine or cosine curve represents half the distance between the maximum and minimum values of a function. It was one of the key features of sine and cosine. Right? And so that's all I'm going to say about it. The period of a sine or cosine function is given by, what's that formula that tells us the period for sine or cosine? Number 4, for the function given by y equals a sine bx minus c, c over b represents the blank blank of the graph of the function. Remember I showed you there were 3 ways to find this. One of those is taking c over b. For the function given by y equals d plus a cosine bx minus c, d represents a blank blank of the graph of the function. And actually, I'm going to give you question 6. It's a bonus question. All right, so for as we talked about tangent, the period of a tangent function is given by blank. So tell me how to find that one. Remember, we just went over how it's a little bit different. that is the end of my podcast. I hope you enjoyed these, and I hope they were very informative, and I'll see you in class. Bye.